Number 34. Assuming a constant temperature coefficient of resistivity, what is the maximum percent decrease in the resistance of a Constantin wire starting at 20 degrees Celsius? All right. So we're asked for maximum percent decrease in the resistance. All right. So the formula that we need to be thinking about then, forget about the term percent. Just think about it in terms of changing resistance values as temperature changes. Right, the formula is the final resistance will be equal to the initial resistance multiplied by 1 plus our temperature coefficient. Oh, that also incorporates some information, right? Multiplied then by the change in temperature. So what's the temperature coefficient for Constantin wire? Well, we just looked that up. Here it is. All right, but notice the main idea is that it's positive. Now, mathematically speaking, if this is positive and the temperature change were to also be positive, okay, that would have then worked out to be a positive value overall for this term. And if I take a positive answer and I add it to 1, then this whole term should be larger than 1, right? And then if this whole term is larger than 1, if I take that number and I multiply it by my initial resistance, that means that the final resistance has to be larger than the initial. For example, if you take 1 and you multiply it by a number larger than 1, like 1.5, the answer is then 1.5. So notice the final is larger than the initial. Okay? Now in this particular problem, they say percent decrease in the resistance. So is this an example of decreasing resistance? No, this is an example of increasing resistance. So the only thing, is the alpha going to change? No, it's not, because they said temperature, assume a constant temperature coefficient. So the only thing that's changing here is how, or possibly the sign for the temperature, okay? This has to work out to be negative. If this works out to be negative, a negative then number multiplied by a positive works out to be negative. 1 then minus a number works out to be less than 1. So instead of 1.5, let's assume it's now 0.5. And what's 1 times 0.5? Well, obviously now it's 0.5. And we went from 1 to then a half, and obviously now we decreased, okay? So in this particular problem for Constantin wire, a negative temperature change will produce the wanted result. If this were carbon, though, we were talking about, then the alpha value becomes negative and everything gets turned on its head. Okay? See the prior problem. So I know now that when I expand on this now, that the final temperature minus the initial, this whole term here, right here, has to work out to be negative. The only way that's going to happen mathematically speaking is that if the initial is larger than the final, right? What's 10 minus 12? Negative 2. What is, 1 minus 10? Negative 9. Notice larger, smaller, okay? That's the pattern. So then I know, I have to think about, well, if it's starting at 20 degrees Celsius, okay, I know this initial is 20 degrees Celsius because that's what they told me. Right? And now my job is to figure out, well, what's the lowest final temperature? Now, they didn't tell us, but it said maximum. So in theory, what's the smallest possible temperature we can ever achieve? What's the theoretical limit? Absolute 0, right? That is, in Kelvin, that's going to be 0 degrees Kelvin. In terms of Celsius now, it's negative 273. Celsius, right? It's really negative 273.15, but honestly, who cares? So here we go. So now we got it, right? So now we are going to calculate the maximum factor, basically, by which this will decrease. So watch, 1 plus now 0.002 times 10 to the minus 3, multiplied by then negative 273 minus 20. Just take out the calculator, plug this all in, okay? So we got negative 273 minus 20 times then 0.002 times 10 to the minus 3. Add 1 to it, and here we go. So we get a number here, number here of 0.999414. All right, so basically now what that means is that, whatever the initial value was, pretend it's 100. Then I would, that's 1,000, 100. Take that and multiply by this, and the final answer then would be 99.9414. So obviously it goes down. Now the question is by what percentage, right? So basically, you can remember this as a basic percentage change formula. You can always take the initial value minus the final value, divide it by the initial value, and multiply it by 100. This represents the percent change. Okay, percent, because it's part over whole, and then percent change, because you have a change value, subtraction in the top. Okay? So essentially now all I need to do is plug in my variables. Percent change, I'll just call percent %C. The initial here in the problem is, we don't know what it is, but let's just plug in RI. The final value then is RF. The initial value is RI times then 100. Now what I'm noticing is that, well, I could cancel these possibly, but in order for me to really cancel the RIs completely, I need another RI here, right? Each factor has to have an RI. And I'm noticing, wait a minute, I have a formula here that already relates RF and RI together. So what I'm going to do is take this thing, because that is equal to RF, and I'm literally just going to, boop, plug it in, okay? So we get RI minus now 0.999414 RI all over RI times N100. Now mathematically speaking, we can simply now cancel it because they're in common, right? Each factor basically has this RI in common, so we cancel them. But be careful. This does not become 0. This does not become 0. Because if that were the case, then this would be undefined, right? That wouldn't make any sense. There's an invisible 1 here, right? There's an invisible 1 there. So basically, just like we didn't cancel this coefficient of this RI, we can't cancel this coefficient and that coefficient. So when we do this, I'm going to do it on the upper left. We get now 1 minus 0.999414 all over 1 times 100. And look at how nice and easy this is. This is the percent change, okay? So let's just do it. 1 minus that value, right, divided by 1, blah, 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 times that by 100. And now we get an answer of this, right? Percent change is going to be equal to 0.0586. That's the percent change. If you need it in 1 sig fig, just round it to 0.06. All right? Depends on what you need. All right, guys. Thank you very much. Hopefully this helped. And please, if it did, help us out. Subscribe, hit that like button. Tell your friends. We'll see you soon. Take care.